In this example, I'm going to show off four things: implementing a loop with a fold, implementing a loop with tail recursion, top-down design, and some details specific to Scala. Even if you are not learning Scala, the other concepts widely apply. Let's say we need to construct a map of color aliases from a sequence of input lines. This might be useful for a product search engine that looks for matching colors first, but also wants to include colors that are close in the search results. Here, for example, we have the color red with color aliases scarlet, ruby, and flame. So on for green and blue. We want to end up with a map from each color to the aliases for that color, as you see here. The first example shown here is a loop that relies on mutable state. I'm not going to cover that here because we're interested in the fold and tail recursion. Next up we have the fold. Scala uses the name fold to refer to a reducer where the initial value is not equal to the first element in the target list. Finally, we have tail recursion. Before we get started, consider where we are in the feedback loop. Remember, feedback loops should be top-down, iterative, and nested. Within the scope of this exercise, the outermost loop is the red-green refactor, where we're getting feedback from succeeding tests. From there, we're going to drop down to the top-down coding loop, where we get feedback from failing tests. And then finally, we're going to even further drop down to the compiler loop, where we're reacting to compiler errors that are highlighted in red by the IDE. So let's get started with the fold with builder test. A feedback loop always starts and ends in the same place. So here I'm looking at test results where I only have the mutable example. An iteration of this loop will end up with a new test, which is the fold with builder example showing up here succeeding. So that's my first loop. So I'm going to get started on that. To get started, I assert that the actual equals the expected. Here you can see on line 79, I assert that the actual color alias map equals the expected color alias map. Since I have not defined the actual color alias map yet, I've actually dropped down all the way to a compiler loop. The start of this loop is that actual color alias map is highlighted in red by the IDE with feedback from the compiler. The end of this loop will be that actual color alias map is no longer highlighted in red. So following the compiler, I define actual color alias map. Since I know I'm doing fold with builder, I grab the color alias map from the builder. That ends the current compiler feedback loop and starts another one. While before, actual color alias map was red, now actual color alias map is not red. So I have ended that compiler loop. However, I've started another one with the builder. Now I have to define what builder is. Since I know I'm doing a fold, I have to start with the color alias lines and then fold over them. And because the signature of fold, I'm going to need an initial value. And I'm going to need a function to process an individual line. Notice I did not worry about the contents of the individual value and the process line function. I just worried about their names. Anytime you have a parameter list, you should not be thinking about what belongs in that parameter list. You should be thinking about the names of what belongs in that parameter list. Now that the builder compiler loop is done, I have started three new compiler loops: initial value, process line, and color alias map. Don't overthink which order to address these in. The compiler will make sure you don't forget anything. Just take the one that seems most obvious to you in the moment. The less obvious ones may become more obvious once that is done. I'm going to start with initial value and set it to an empty builder. That addresses initial value and makes me aware of a builder class. Again, I have three choices, so in this case I'm going to decide to follow the builder class. Now I only have two choices, and now that I have a builder class, the color alias map field is a lot easier to deal with. This created a problem with initializing the builder. So let's define an initial value. Now only process line is left, and since it is used in a fold, we know what its signature must be. This triple question mark in Scala is just defined as throwing a not implemented error. Finally, I've run out of compiler loops, so I unwind one level to the failing test loop. So I run the test here, and there we go, failing test. At each iteration of the failing test loop, I should be getting a little further along before the test fails, until the test finally succeeds and I unwind yet again to the red-green refactor loop. So I don't worry about what to do next. I simply follow the test here, and I see I have something not implemented. So let's implement this. And remember, at each stage, we want to do the simplest possible thing that makes progress. In this case, I'm just going to delegate to the accumulator. And now I have dropped down into a compiler loop. Next up, I need a process line method on the builder. And finally, I've run out of compiler loops again, so I'm back to a failing test loop. So let's run that. And there we go. And I see exactly where I am. So again, I want to do the simplest thing that makes some progress. So here I just did one thing. I realized that I need to process the line differently depending on whether it's a color or an alias. So I do that and only that here. And now I follow the test to figure out what to do next. So it looks like the color is up. So if you've been following along, you should notice I'm only ever doing the simplest thing that can make some progress. So it might be a good idea to pause the video now and actually try and guess what I'm about to type here. You back? All right, let's see how well you did. That's it. We just drop down to a compiler loop. We delegate to something that processes the color because each piece of code here only does one thing. Next up, let's define process color. So did you think to have the empty implementation? Remember, one thing at a time. Let's go to our next failing test loop. And we just follow that failing test to see what to do next. And it looks like we're still on process color. So here we realize that when we process a color, we have to change the color that we're currently processing. So I want to make a copy of this builder. And set the current color to the color that was just processed. Now I'm dropping into a compiler loop. So to add support for copy, I make this a case class. And I need a current color. And there we go. Now I noticed I have to initialize the builder with a current color. So let's take care of that. So notice I could have hard-coded this default color to just none, but notice that I have more information. What does none mean? Well, we know what it means. We know none means the default color. Now that I got it compiling, let's run the test again. And following that test where it leads, we now have to deal with an alias. So hopefully you're able to guess what this is going to be. And run the test again. All right, now it's time to implement the alias. So that is going to be very similar. It's going to be a copy of the color alias map equals the new color alias map. So what's the new color alias map going to be? It's going to be the color alias map updated with the current color aliases being the new aliases. Okay, so what are the new aliases? Well, that just equals the old aliases, and we'll just append the alias. Oh, so what are the old aliases? That comes from the color alias map of the current color. And now let's run the test. Okay, key not found red. After a little thinking about this, we realized that when we grab something from a color we've never seen before, there's nothing that tells the initial alias list to default to an empty list. So let's just fix that right here. And there we have it. We have a fold with builder done completely top down. And we have finished a single iteration of the red-green refactor loop. And notice each loop starts where it ends. We started here by looking that we only had mutable loop. Now we have a fold with builder loop, also successful. Now let's do another iteration of the red-green refactor loop. So to make progress towards the next iteration of our red-green refactor loop, we just create a new test and we set the actual color alias map equal to the expected color alias map. So again, compiler tells us what we need to do next. Okay, so I fixed that compiler loop, start another one. Now we need a process lines function. And now we ended a failing test loop. So we know where to make progress. Let's get this working. So recursive functions are a little tricky because you have to deal with both the base case and the recursive step. So right now I'm just going to deal with the base case, and I'm going to, in my case, the base case is when lines is empty. So I'm just going to return the color alias map. So the color alias map has to come from somewhere, so I'm going to put it right in the signature. But now I've made things more troublesome for the caller because now the caller has to worry about these initial values, and I don't want the calling code to have to deal with that. So I'm going to actually split this up into two methods. So now I run it again, and we see that we did not start with a base case. So now let's deal with the recursive case. If lines are empty, then we have our base case. Otherwise, we want to come up with the simplest possible thing to make progress on the recursive case. And for that, we know that we have to deal with the recursive case differently depending on what kind of line it is. And now the line has to come from somewhere, which we know is safe because we know the line is not empty. Now let's run again. And it looks like the color is the first thing we have to deal with. So let's go ahead and deal with that. So since the current color has changed, nothing from the color alias map changes, so that stays the same. But the current color does change, so let's pass that along in the parameter list. And then let's pass along our remaining lines. Okay, now two things to deal with. Let's deal with remaining lines. Okay, and now let's deal with the current color. And run the test. We need an initial value for the current color. And run the test again. And now we have to deal with aliases. And in this case, we're going to have a new color alias map. We're going to keep the current color, and again, process the remaining lines. So what is the new color alias map? It equals the color alias map updated from the current color to the new aliases. So what's the new aliases? Well, that's the old aliases with the new alias concatenated. Now what's the old aliases? The color alias map for the current color. And let's run the test again. And here we see we don't default to an empty list. So let's handle that in our initial color alias map. And there we have the recursive solution done entirely in top-down design. Now there's a couple of Scala quirks here. If you expect that the recursion is happening in the tail position, Scala can do an optimization that makes it compile to a loop instead of a recursive call, saving on your stack space. So the way you declare your intent of that is you use this Scala annotation called tailrec. Now this doesn't change the code that is generated. The code that's generated will be the same whether you put tailrec in there or not. If the compiler can optimize your recursive call to a loop, it will. The tailrec is just you expressing your intent that you believe that the recursion is happening at the tail position. And if it's not, the compiler will blow up. So this is a way to protect yourself against accidentally not having recursion in the tail position. The other noteworthy thing here is look at what we're doing with this lines. This lines is a sequence. So if you look at what we're doing with lines, we check if it's empty, we check its head, we check its tail. Now, these operations are very optimal for a singly linked list. So in order to enforce that, let's go ahead and make this a singly linked list and try to run the test. Now here we see that, well, we didn't specify an implementation detail here. So here I can just do toList. So this is a bit of a trade-off. By here, if the lines was not in a singly linked list, we're paying the cost to convert it to a singly linked list right here. But what we're getting in return from that is we've shielded the caller from knowing about that implementation detail. So while we've taken some power away from the caller, we've also created more abstraction for the caller. And we only have to do this conversion once. Now for the recursive function itself, it always knows it's dealing with a list of strings, so it can safely make these calls and it will be O of one time. So that's how you implement the same loop with recursion in top-down fashion. So going back to the feedback loop, we were in two red-green refactor feedback loops, one for the fold with builder and another for the recursion, and we were constantly dropping down to these quicker feedback loops. This feedback loop style gives you guidance that keeps you from getting stuck and makes programming more interesting and more fun. It's no fun being stuck, but it's really satisfying to have all these small victories one after the other. The feedback loop makes sure you always know what to do and that you won't have to wait long before achieving some objectively measurable progress. You also save a lot of time by not getting sidetracked with anything you don't need. The fastest programmer in the world can't code faster than you realizing you don't need to code it at all. Remember, always know the outer feedback loop that is driving the one you are currently in. Constantly be pushing towards smaller, shorter iterations. At the end of this, you will finish a really small task, start unwinding towards the top of the feedback loop, and realize, oh, I'm done.